Hello everyone. Today we are going to learn 5.3 non-homogeneous linear equation. So we learned so far homogeneous linear equation, right? But then this time is non-homogeneous. So let's talk about that. Let me make a little bit bigger for volume. Okay, so if we had this equation, so let's take a look. Y prime plus P of X, Y prime, did I say Y prime? Y second prime plus P of X, Y prime plus Q of X times Y equal to F of X, right? If we had zero other side, that is a homogeneous linear equation. In that case, second order, right? We knew that. Yeah. Then we have f of x. It can be just constant function or just a function, right? So f of x, that is non-homogeneous. Yeah, we knew. Okay, so we have a theorem. We have a non-homogeneous linear equation with initial value, right? Since we have a second order linear, right? So we have two initial, which is yx naught equal to k sub naught and y prime x naught equal to k sub 1. And then we say that, they say that has unique solution. Yeah. And then the real numbers with the real numbers. Yeah. Okay, now we have another terminology here. So let's take a look. In the homogeneous equation, right? So we had the other side is 0, right? Instead of f of x. Yeah. If we have f of x, that's non-homogeneous, right? We just learned, right? Then we have a complementary equation. So what this means? So this means to find the general solution of the associated homogeneous equation. So associated homogeneous equation, when you find the general solution, right? So we called complementary equation, right? Then what's the difference with the general solution? Yeah, let's take a look. So we make a symbol y sub p, this p from particular solution. Yeah. Okay, then we have a complementary equation. So we have here, let's take a look. Okay, so we have another theorem. So y sub p is a particular solution, right? In the non-homogeneous second linear order, right? Okay, then we say that y sub 1, y sub 2 be solutions of complementary equation, right? So we just had that complementary equation is associated with homogeneous, right? Equation. So we are using other side equal to 0. Then the y is solution. Okay, IFF means if and only if y equal to, look, we have particular solution plus we have c sub 1, y sub 1, c sub 2, y sub 2. We've seen this one before, right? So normally we say that if we have in previously, right? Y equal to then c sub 1, y sub 1 plus c sub 2, y sub 2, right? We denote it this way, right? And then we say that this is a general solution, right? Okay, now we say that this part will be complementary equation, and then I want to denote y sub c, so first letter from the c. Make sense? Yeah. So c, so c, yeah. So particular solution, we are using just the first letter p, so y sub p. And then complementary equation, we are using first letter c, so y sub c. Make sense? Okay, so let us do, yeah. Okay, so basically, general solution in this section for non-homogeneous linear second order equation, we have particular solution plus complementary equation or complementary solution, right? Particular solution with complementary solution, yeah? And then that complementary solution consists of like this, right? Which is we had previously general solution. Make sense to you? Okay, so let us do example. Let me put this one here. Okay, so we have find the general solution. So general solution will be, in that case, we will have y equal to y sub p plus y sub c, means that we will have particular solution with the complementary equation, complementary solution, right? Okay, let us do this one. So we have y second prime minus 4y prime plus 5y equal to 1 plus 5x. Yeah, this is f of x, non-homogeneous equation, right? Okay, now we can express this equation with this form, right? Since we have a y second prime and then y prime and y, right? So this will be r squared minus 4r plus 5 equal to 0. Yeah. Okay, then we want to check whether they have real root, complex root, or repeated root, right? Okay, let's find out. Check it out. Yeah, so we have a b squared minus a 4ac. So b in that case, abc, right? So we calculate b squared minus a 4ac, then we get negative 4 less than 0. So inside the square root, b squared minus 4ac, which is a discriminant, right? So negative is a complex root. We talked before, right? So we cannot have inside the square root negative because there's a complex number, right? Okay, then if we have complex root, then we have a form, we have to use their form, right? So that is y equal to e to the lambda x times, we have c sub 1 cosine omega x plus c sub 2 sine omega x, yeah? Okay, then how do you find this lambda? So lambda has negative b over 2a, the formula, right? And omega has square root 4ac minus b squared over 2a, right? So we just apply the formula here. Yeah? Okay, let's do it. So lambda. So lambda equal to negative b, negative 4. But then we have a negative, right? So we have a negative, right? Or we can just say the positive 4, negative 4 over 2a, so 2, 1, right? So we will get 2, right? omega equal to, so 4 times a times c minus b squared, so negative 4 squared over 2a, right? So it's 2. Now, can you please calculate? So that will be square root 20 minus 16 over 2, which is 4 over 2, which is 1, right? Okay, now we knew lambda, which is equal to 2, omega, which is equal to 1, so we can express y equal to e to the lambda, which is 2x, c sub 1 cosine omega, which is 1, x, plus c sub 2 sine omega, which is 1 times x. Yeah. Okay. So we could, this will be this form. So we say the complementary equation. Yeah. Complement. Complementary, sorry, mentary, not the ment. Complementary equation. Let me denote equation like that. Okay. All right. We want to find, because our goal is to find general solution, right? So general solution, the form is particular solution with complementary equation, right? Okay, so particular solution, how do you find? So let us do that. Let me add one more page here. Okay, so particular solution. Particular solution. Y sub p, right? Okay, so let me bring the original equation here. Okay, then look, the right side is telling us non-homogeneous, right? Equation, because it's not zero, right? So we can guess this is a form of linear. Can you see that? So we can say that let y sub p, which is a particular solution, will be the form of a plus bx, which is linear too, right? Okay, now let's derivative. All right, so first term is 0. Second term is b, right? Which is b, right? Okay, what about with second derivative, right? So constant, so we get 0. Yeah. Okay, now we have the form again. Let me rewrite. So we have y second prime minus 4y prime plus 5y equal to 1 plus 5x. Okay, let's substitute y second prime, which is 0. Yeah. Minus 4y prime, which is b, plus 5y, y has a plus bx equal to 1 plus 5x. Yeah. So let me do this one. This is a y prime. And this is a y prime. Sorry, y second prime, y prime. And this is y. Yeah. Okay. All right. Then let's take a look. I want to distribute. So we have a negative 4b plus 5a plus 5bx equal to 1 plus 5x. Yeah. Okay. Can you see that? This one corresponding with 5bx corresponding with 5x on the x itself, right? And then can you see that this is corresponding with this one? Yeah, constant term means that. Yeah, a little bit bigger, better color. Not good. Okay. Yeah, I just want to label it. And okay. All right, so let me rewrite those, right? So let's see, 5x first. 5bx equal to 5x. Yeah, that means 5b equal to 5, right? Okay, then solve for b. What do you get? Then b will be 1, right? Okay, very good. How about the constant term? We have a negative 4b plus 5a equal to 1, right? Okay, then b equal to 1, so we have a negative 4b 1 plus 5a equal to 1 and solve for a, right? So we get negative 4 negative 4 and positive 4, so 5a equal to 5, right? So a equal to also 1, right? Okay. Let's write in. So this is, we say the particular solution has a form which is a linear form, right? A plus bx, right? So let me conclude. So 3 dot means conclusion. Particular solution equal to a plus bx. We studied earlier, right? So there will be a equal to 1, b equal to 1. So we get 1 plus x. Yeah, that will be particular solution. So we have altogether general solution, which is particular solution plus the complementary equation, right? So y sub p plus y sub c, 1 plus x plus complementary solution we had, oh, e to the x, 2x, I'm sorry, e to the 2x, c sub 1 cosine x plus c sub 2 sine x. Yeah, let me rewrite here. E to the 2x, c sub 1 cosine x plus c sub 2 sine x. Okay. Make sense? Okay. Very good. Let's do second question here. So we have find the general solution of the equation, right? Let's take a look at this one. This is not the linear form, right? It's a quadratic. Okay, let's find complementary equation, right? So basically complementary equation like what we did earlier previously, right? Previous sections, right? Okay, this one we added there, right? Non-homogeneous equation, right? So we found from here we need to find the particular solution. Make sense? Okay, so let us do that. Same concept. We have four complementary, right? So let me just a four complementary equation, right? All right. So left side we have y second prime minus 2y prime plus y, and then complementary equation associated with homogeneous equation, right? So make it equal to 0. All right, then left hand side, yeah. Okay, then we can express this one as r squared minus 2r plus 1, right? The constant equal to 0. Okay, can you factor out? So r times r. How can you factor 1 and 1? And negative, negative, right? Okay, now that means r minus 1 quantity square equal to 0 means that we have 0 with repeated, right? So, oh, okay, let me bring the note here. Okay, I brought this note. So we had a repeated root. We can just using the notation R sub 1. Then the general solution is y equal to e to the R sub 1 x times c sub 1 plus c sub 2 times x, right? So the previous section we were using general solution, right? But now it will be particular solution. Yeah. Okay. So let us do this. So let r sub 1 equal to 1 in that case, right? So let r sub 1 equal to 1. So we have a particular solution will be just following that, right? Following this. So there will be e to the r sub 1x, c sub 1 plus c sub 2x. There will be e sub r sub 1, which is 1 times x, and c sub 1 plus c sub 2x. Yeah. Okay. If we distribute, we will get the e to the x, c sub 1. Let me write in c sub 1 in the front. E to the x power plus c sub 2 and x e to the x power, right? Okay. That is particular solution, right? Okay, let's work particular solution, complementary equation, complementary solution, yeah? So then we are looking at the f of x non-homogeneous equation, right? So we have that, right? Okay. So 4 the complementary equation, right? Okay, so take a look, right hand side. So we have this form is not the linear, right? We had the linear form earlier, yeah? So this one is called quadratic form, right? Quadratic equation, right? So this is quadratic equation. So we can writing the form, which is what is where what I get the pure sub c, y sub c, right? Okay, let me fix that. Y sub c, y sub c. Okay, so y sub c we can express as, oh my gosh, I'm crazy. So sorry about that. We found, no, we found, hold on one second. Did I make a screw up? So this is complementary, yeah? Why I say that? Complementary, crazy. And this is, I screw up, right? So this is a particular solution. Okay, I'm very sorry. So we found complementary equation. Now we need to find the particular solution. Yeah, sorry about that terminology. Okay, so we can write in the particular solution, which is quadratic form, that is ax squared plus bx plus c form. That's the quadratic equation form, right? Okay, now what is the derivative of that, right? Then there will be times 2x, right? 2ax, sorry, 2ax plus derivative b, right? Then the constant is 0, right? Okay, now we want to find another derivative, right? So second derivative, which is 2a there, and then 0. Yeah. Okay, now let me bring the equation here. And then we substitute y second prime, y prime in y, right? Okay, so we have y second prime, which is 2a, minus 2y prime, we have 2ax plus b plus y is ax squared plus bx plus c, yeah? Okay, equal to -3 minus x plus x squared, yeah? So that will be y second prime, y prime, y, yeah? Okay, so let's find what is a, b, c, like earlier, right? Before we do that, we need distribute. So we have a 2a minus distribute for ax minus 2b plus ax squared plus bx plus c equal to -3 minus x plus x squared, right? Okay, let's arrange constant. So we have a constant 2a minus 2b plus c, and the first order. So we have a plus negative 4a plus b, which is x term, right? And ax squared, right? Equal to negative 3 minus x plus x squared, right? Let me double check. Okay, so we good? All right. Okay, now this is corresponding. This is corresponding, right? X squared, ax squared, x squared. And this one corresponding. Yeah. And this one corresponding constant with a constant. Yeah. Okay. So let's arrange. So we have a x squared equal to x squared. There will be a equal to 1. Good. Now we have negative 4a plus b x equal to negative x. Yeah. Okay, so that means negative 4a plus b equal to negative 1, right? And then we have a equal to 1, so negative 4a, which is 1 plus b equal to negative 1. So move to the negative 4 to the other side, so it's positive. So we have b equal to 3 then, right? Yeah. B equal to 3, yeah. Okay, the last one, so we have a constant term. So we have 2a minus 2b plus c equal to negative 3, right? Okay, so that will be 2a equal to 1, b equal to 3. And we need to solve for c, right? So what do you get? So 2, 6. Negative 4 and move other side. So C will be positive 1. Yeah. Okay, very good. Okay, let's conclude. I need a space. Okay, now I should be careful. We found the complementary solution earlier. So this is particular solution, right? So y is the p equal to, which is quadratic form, quadratic equation ax squared plus bx plus c, right? So we have a, which is 1, x squared, b, which is 3 plus 3x, c, which is plus 1. Yeah. Okay, now we have general solution. Earlier, there is no space, I couldn't writing out. So general solution, we are using y equal to uh, complementary solution plus particular solution, right? Okay, there will be complementary solution will be this one, right? Copy. And particular solution will be x squared plus 3x plus 1. Yeah? Okay. Now, let us find with the initial value. Let's do it. Yeah? Okay. So we want to find such a C, right? That's why they have initial value, right? So y equal to. Okay, so solve the initial value problem, right? Okay, the given information y of 0 equal to -2 and y prime of 0 equal to 1. So this general solution from previous, right? Here, okay? Okay, now let us do that. Uh, y prime. So we want to find y prime first. So y prime equal to, okay, so derivative of first term. Yeah, as it is, right? Okay, derivative of second term. So we have x, we have e to the x power. So we are using product rule. So f times g, which is equal to f prime, g plus f, g prime, right? Okay, so that will be f prime, sorry, c sub 2, g e to the x plus f c sub 2x g prime e to the x power. Yeah, plus the rest. Derivative x squared 2x. Derivative of 3x, 3. Okay, so we done, right? All right, then we are using the initial. So let's make a initial value that is x, right? Okay, so there will be y of 0 equal to and c sub 1 x equal to 0 plus c sub 2 x equal to 0 e to the 0 plus 0 plus 0 plus 1 equal to -2, right? Okay, so there will be c sub 1 plus, this is 0, and we have 1, right? So c sub 1 plus 1 equal to -2. So c sub 1 will be then -3 then, yeah? Okay, now y sub 0, y sub, y prime of 0 equal to, okay, we substitute 0 into the x. This is x. So there will be c sub 1 e to the 0 plus c sub 2 e to the 0 plus c sub 2 0 e to the 0 plus 2 0 plus 3 equal to, they say that it's 1. So it's 1. Okay. We get c sub 1 plus c sub 2. And the third term is 0. And 2 times 0 is 0 plus 3 equal to 1, right? Okay, now c sub 1 we knew it's a -3 plus c sub 2. Okay, then c sub 2 will be 1 then, yeah? Okay, now we have the general solution, yeah? So y of x c sub 1 is e to the x power plus c sub 2x e to the x plus x squared plus 3x plus 1. And c sub 1 we have -3, right? E to the x power plus c sub 1, which is 1. So x e to the x plus x squared plus 3x plus 1. Yeah. Okay. Oh yeah, this will be the last example here. Okay. Thank you for watching. See you. Bye-bye.